Today's goal is to look at how equations can help us describe relationships and constraints. Yesterday, I know was like a bit of like a weirder lesson, but the main goal of yesterday's lesson is to learn what constraints are. So what are constraints? Things that limit you, right? So like, say if we were planning a pizza party, like maybe our budget, maybe the number of pizzas that we can buy, things like that, things that are reasonable and unreasonable. Like it would be unreasonable to buy like 50 pizzas and there's like 36 people in here. You know, those would be examples of constraints. And we learned some ways, we just kind of like barely dip our toes, learned some ways to write those constraints, those relationships. And today we're specifically looking at equations. So what makes equations? The equal sign. So could equations have all numbers as long as there's an equal sign in there? Could it be all letters? As long as there's an equal sign in there. And then it could be a combination of both. So there's that. Then today, by the end of the lesson, you should be able to tell which quantities in a situation can vary and which ones cannot, and be able to use letters and numbers to write equations representing the relationships in a situation. I'm recording right now, I'll link it in the slides. I do have my recordings from last year also linked, so I know some people have reached out and said that they know they're going out of town or something like that. Well, you could get ahead if you want to. Like all the recordings are there, and then so are the practices. Granted, you might not know how to do the practice until we do the lesson, but then if you ever need more attempts, you just let me know. But those are all available too. So you should have done the lesson 1 yesterday. If not, just get it done as soon as you can. And now we're on lesson 2. I never try to make the practices more than like 6 questions, maybe at most 10 if some of those questions are like really short. So just keep that in mind. Anyway, this is probably like the last time I'll remind you about your binder test. Otherwise, there's a comment in Infinite Campus about when you can resubmit. So, or like up until the last day you can resubmit. As long as I'm not in the middle of teaching, you just have to remind me, say like, hey, Miss Medina, I have my binder ready, and then I'll check it. But again, just not while I'm in the middle of teaching this time. I talked about this yesterday. Still working on grading all the retakes for the constructed response portion and some of the retakes for the multiple choice portion. But you'll know that your grade is that final grade when you see the comment in Schoology and in Infinite Campus that says retake given during class time, higher of 2 scores given. So for some people, they scored better the first time, so it kind of looks like their grade didn't change. But most people scored better the second time. So then you definitely saw that change and that comment. Yes? Yes. All right, and then once I'm done grading the constructed response part, you'll see that comment in there once it's finalized. I do have office hours today. I imagine that there will be a big group because I mentioned that if you still don't like your grade, or either portion really, what you would need to do are corrections. Like you're not just going to be able to retake it right off the bat. I already gave you a retake. Like you would have to show me that you actually like studied, tried, seeked to understand before we even cross that bridge. Because really, technically, you should only get the 1 retake and then be done. But I know some of you, that's like the only thing that's keeping you from passing. And some of you have unique situations, all this stuff. Plan on coming to office hours today if that's something that matters to you, your grades on either of these tests. All right, but anyway, you could expect the next quiz to be on Monday, usually on Mondays until further notice. And then I already have the dates for the next unit test in advance and binder test and all that stuff. So questions on that? Yes.
So I have a thing on
So Wednesdays are the days that I'm available. So sorry, you'll have to plan for next Wednesday if you want to come to my office hours. There are other algebra teachers available on Tuesdays if you ever want to come and get extra help from them, if you want to like do something else, like test corrections or retakes, I need to know in advance so that I can give them the materials. Okay, but other than that, you know, I'm really only available on Wednesdays. I practice like almost every day with my team, except for Wednesdays. I miss out on practice to be here. So like, I know lots of coaches are usually flexible. I know away games are a bit different, but just know that, everyone. Make it a priority. I make it a priority. I was actually planning on not even coming today, but I was like having like a really bad migraine all night. But I still came because one, I didn't feel like writing sub plans because then I was like, I'm not able to be here. And then two, I knew like people would assume that office hours were canceled when they're not. Like I still would have come to office hours even if I didn't come to work today. If I ever decide that a Wednesday I'm not available, I will email you and all your parents. All right, because I know like some parents rearrange their schedules and make it a priority as they should. But like, yeah, I always try to prioritize Wednesday office hours. For questions on anything else. Okay. So there's that. You can always get extra help Tuesdays from other people, and then Wednesdays are the days that I'm available. All right, but moving on to this lesson. So I'm gonna remind you, math talks are only on the screen. I show you like one problem at a time. You try to solve it in your head without a calculator and without any scratch work. You guys have to pull up this for you? Pause this. Okay, so so for the math talks, I show you them one at a time. When you think you have the answer, put your thumb up. You're not supposed to do any scratch work or calculator work. When we go over them, you could jot stuff down if you want to. You don't need to. All right, so then here is the first one. All right, so evaluate in your head 25% of 200. Put your thumb up when you think you have the answer. So I'm looking for those thumbs when you think you have it. Do the last one. And then very all lowercase. Okay, so let's see, Messiah, what'd you get for 25% of 200? Anyone get something different than this? Okay, so then Josiah, how did you come to that conclusion?
Well, 100% would be 200. So we divide by divide that by half now.
It's all right.
I
Your thinking is not wrong, I'll try to follow it. So you did 100% of 200 is 200, is that what you said?
50% of 200.
Okay. 50% of 200 is 100, and then what did you do? That's what you did? Okay, did anyone do it differently? That's still good to stay in. Parker?
25% on 100, which is 25.
Okay, did anyone do it differently than that? No, everyone did it the same. Did anyone do it in their head as the 200 times 0.25 and then did all that math? Okay, well, that is something I usually hear. All right, now that is correct. It is 50. On to the next one. 12% of 200. And come up when you think you have the answer. Okay, 12% of 200. Come up when you think you have the answer.
And you do be a good problem solver, because now it was right there.
I'm looking for those 12% of 200. All right, Tristan, what'd you get?
Oh, I got 24.
24. Anyone get something other than that? Okay, then how did you get to that, Tristan?
I did a little shorter than I did. Took 12% of 100, which is 12, and then I doubled it.
Okay. Did everyone else who got that get the same thing? Anyone do it a different way? Okay, I think this one's the last one. 8% of 200. So looking for those thumbs when you think you have it. So consider some of the other methods that you are solved. Barnaby, what'd you get? And how did you get that? Half of what? Half of 100. Okay, anyone get it a different way? Or can explain it a different way? All right, so, good thought processes. I didn't see anyone do it this way, although that is another way that you could have done it. Like if you were putting it in your calculator, you would have had to do times 0.25, times in it by 25, wouldn't really tell you the answer. But this is good logic. This is what I would have done too, is compare it to 100s, because percents are usually out of 100%, and then just go from there, whatever direction. All right, so good. Now, this I believe is on your paper. Correct me if it's not. But what you are going to be doing now in your groups is write an equation to represent each situation. There's a handful of them. Work through them. Maybe we'll do like the first one together. So we have blueberries are $4.99 a pound. Diego buys B pounds of blueberries and pays $14.95. So whenever I'm doing word problems, especially when I know they're gonna be equations, I usually start with any totals. What are my totals in A? That's where I usually start. Because usually totals are alone on one side of the equal sign. The other side is what contributes to that total. So what contributes to the $14.95? The $4.99. Now I know I'm not done because I know that these don't equal each other, right? So what else needs to be with that $4.99? The variable. Will it be added, multiplied, divided, subtracted? Multiplied. Because I don't know if you've ever bought anything at a grocery store, but it's usually however many you buy determines how much you have to pay at the end, right? Usually you multiply that. Am I missing anything? Do I have all the numbers involved, all the variables that they said we should use? All right, so then that looks good. So then go through the rest of the list, and you could use the method that I use. You could probably still come to it a different way. One more thing before I let you start. Would it be okay to write it like this? Yes, there's no rule that the total has to be on the left or the right. I will say though, like, when it's a number times a variable, usually we write the number first. So that it's a coefficient and a variable, so that they're like together. If you did b times 499, I'm sure it does mean the same thing, but like, try to put the number in front of the variable. So questions on anything I just said? All right, then try the rest with your group. Since there's 5 of them, I'll start with like 6 minutes. I know word problems tend to be harder for you guys. You aren't actually solving them, you are just writing them to represent. So we have blueberries are $4.99 a pound. Jada buys P pounds of blueberries and pays C dollars. What did you guys write? Whoever the reporter is. Okay, be respectful to your peers. I heard C equals $4.99 and then what? All right, anyone write it differently? Oh, sorry. Anyone write it differently than that? Okay, it looks good to me. This time, and really, if you compare it to the one directly above it, the only thing that's changing is now it's Jada buying B pounds instead of B pounds and paying C dollars instead of $14.95. All right, so it really could look similar to what we had already, just now with those changes. Questions on that? All right, then table 7, what about the next one? We have blueberries are D dollars a pound. Lynn buys Q pounds of blueberries and pays T dollars. Q equals what? Okay. All right, so did I get it right now? Okay. Anyone write something different than that?
Just did the same thing.
Okay, so T equals DQ. Could it be UD? It could be, again, you're a little bit right about it not looking right. Usually when we have multiple variables, we put them in alphabetical order, but we haven't gotten that far yet. But right now, you need to know, like, order for multiplication doesn't really change anything. 3 times 2 is still 6, as like 2 times 3 is still 6. But yeah, you can have any variation of this and be fine. All right, now next table, table 8. What about Noah earned N dollars over the summer? May earned 275, which is 45 more than Noah did.
So we did, 275 minus 25.
Okay, do we like that, class? So if she earned 275, which is 45 more than Noah did, and what Noah earned is N, what did Noah earn? 230 is correct, because she earned more than what Noah did. So you wouldn't want to add the 45 to N. Or actually, yeah, like to figure out what Noah earned, you wouldn't add 45 to what May earned. You would have to subtract it. Could you write it a different way? Is that what you're going to tell me?
Yeah.
Okay.
275 minus.
I think that's true, right? Oh, it's true, but
Yes.
Yeah, is it a rule that all the variables have to be on one side? All right, no. That's still saying the same thing. Is there even another way that we could write it? N plus 45 equals 275. All right, what Noah earned plus the $45 would give me what May earned. So these are all correct. If you have even another one that you want to tell me, you know, you can let me know, we can see if it's right. But there are multiple ways to set it up and still be right. You could argue that some ways are easier than others. Like some might think that this is easier because the variable's on one side and then you just have to do one step, which is subtract. All right, but that's up to you. On the next one, table 1. Noah earned B dollars over the summer. May earned M dollars, which is $45 more than Noah did. What did you guys get? All right, class, agree, disagree, agree. This one looks most similar to this one up here. So really, you could kind of use it to help you set up. If you didn't already have that answer. So there's other ways that you could write this one. What's another way? Feel free to use these ones as models. Okay. Okay, that too. Same thing, just flip. Anything else? Okay, let me throw this one up there that I don't think was said yet. Would this be equivalent? B equals negative 45 plus M. Okay, one, yeah. Anyone else want to chime in? All right, this still would be equivalent. So over here, in both of these relationships, actually, the 45 is negative. All I did was change the order, but I still kept this negative and I still kept this positive. That is allowed. Would you logically set it up that way? Probably not, but you could. Parker?
I did, and minus.
And minus B equals what? 45. Okay, so what my earned minus what Noah earned is $45. That makes sense. Any other things we want to throw out there? Are we seeing that you could do multiple things and it still be right? There are also some things you can do that could be wrong, but like, as long as we're not breaking any like math laws, then it should be fine. All right, last one, table 2. Noah earned W dollars over the summer. May earned X dollars, which is Y dollars more than Noah did. X minus Y equals W. Okay. So she earned X dollars, which is Y dollars more than what Noah did. Okay, that works. Is there other ways you could write that? Can someone give me another way, Josiah? Okay, good. Others, Parker? Okay, that works too. Any other ones? Now, I know it's a bit harder when they're all variables, because then you really have to go back and look to see if it makes sense. But I think you can go away. And you can just put in the. But I know, like, I'm pretty good at math. I know that if I wanted to maybe isolate the X, in order to cancel out a minus W, what's the opposite of minus and W? So then I could also do X equals, I'll put it over here, Y plus W. Because it's a rule that whatever you do on one side of the equal sign, you have to do to the other side. So even with variables, they follow the same rules. If I want to cancel something, I need to do the opposite. So to make this one, I did adding W on each side, so this would also work. Just depends on what you want to isolate. So questions on this activity? All right, we're almost done, just a few more examples. If you want to write them on the back, you can, but I know we already selected that. So how are the equations you wrote for the blueberry purchases, like the equations you wrote for May and Noah's summer earnings? Table 1. How are the equations that we wrote for the blueberry purchases like the equations we wrote for May and Noah's summer earnings? Don't make it too complicated. So give me one thing that's similar. Okay, I'm gonna call in another group, but then you can't take their answer. All right, Keegan, they both have variables.
Oh.
Okay, so now table 1, you have to come up with something else. They both have constants. What are constants, class? Numbers that aren't attached to the variable. So like, let's look back at our examples. But like, we do have 1495 as a constant, 275 as a constant, 45 as a constant, right? Is 499 a constant? No. So that could be a thing of how they're different. I don't think down here we had any coefficients, so you could put that for how they are different. So we could put my and Noah's equation had constants, or not constants, had coefficients. Anything else that we observed? I think those were the major ones. How did you know when something could vary in a situation? When it was marked as a variable. Because what didn't change when we talked about May and Noah's earnings, for example? The total that May earned, right? That didn't change. That's not what is varying, and so forth. So things like that. Let's see. Other main points before I let you move on to the practice. Let's do this. I think it's a good practice one, and then I'll let you work on your puzzle piece practice. So we have the tax on the sale of a car in Michigan is 6%. At a dealership in Ann Arbor, a car purchase also involves $120 in miscellaneous charges. There are several quantities in this situation: the original car price, sales tax, miscellaneous charges, and the total price. Write an equation to describe the relationship between all the quantities when the original car price is $9,500 and then the total price is $22,408. All right, you could jot your equation on the back if you want. Just this last problem, I'll give you like 3 minutes to work it out with your groups. We'll go over it and then we'll work on the practice. Word problem. Well, numbers I would probably look for second. Variables maybe, I don't know, last. But what did I tell you that I always look for first that I think makes it easier? Totals. Because what are totals usually alone and next to? Equal sign. So in this first one where they're saying the original car price is $9,500, do we know the total of the car and any of this other stuff? So then in that case, I could label it a variable and we can call it T. I don't think they gave us a variable for the total, so we have to make it up ourselves. All right, now what contributes to the total? So this is where then I probably look for numbers. So I have like 6% at the dealership in Michigan. At a different dealership, it's $120. So that won't be in the same equation. It'll be one for Michigan and one for the Ann Arbor, because they're different. So what contributes to the total cost of this car? One thing that contributes to it,
Total price.
the original price of the car, because that won't necessarily match my total price. We don't actually know the total price. So 9,500. For Michigan, it gave us that it's 6% interest. Would that add to the cost or subtract from it? And it's actually tax, not interest, but it would add to it. And then what would I write?
Plus your variable.
What we could figure out what 6% is of 9,500. Do you know how to figure that out? Okay, then I'll tell you this one time. It would be 9,500 times 6% as a decimal, which is 0.06. Let me move this equals. All right, because we need to figure out what 6% is of 9,500. And then add it to the cost, so that's like on top of that, make sense? Okay, so then that covers Michigan. It didn't say anything about miscellaneous charges on that one, so I'm assuming there are none. And then Ann Arbor, we don't know the total yet. I suppose we could figure it out. But we know that the original cost was 9,500. Didn't mention anything about sales tax for that, so assuming they don't have it or that it could be a variable. And then how do I factor in the miscellaneous charges? Yeah, because it would add to the price, right? Not take away from it. I have a feeling it wants still for you to put the tax, so if you were putting the tax on this, it would be 9,500 times something that represents the tax. I don't want to use T, so I'll use X. And then over here, if we're doing like a miscellaneous charge, we could add M. All of that would contribute to the total cost. Does that make sense? And then down here, now they're giving us that the total price is 22,480. So they're taking away that fact that we know the original price was 9,500. So anywhere that we had the original price, we could put a variable. What letter do you want to use? Well, we already used X for tax, so maybe use a different one. A, sure. So then everywhere that there's the 9,500, I'm gonna replace it with A. But now we know that the total price is the 22,480. And then for the Ann Arbor example, anywhere that there's 9,500, we could put A. But now we know that the total is 22,480. There could be variations that are still right, but the main thing here is knowing what quantities can change and what cannot, how to represent those. And then things that aren't changing. Like in Ann Arbor, the miscellaneous fee is $120 no matter what, so it's a constant. Over here, the original price, or sorry, the tax is 6% no matter what, so that's a constant. Does that make sense? Okay. Well, if not, use that puzzle piece to try to see. to get some more practice in. You should be working on unit 2 puzzle pieces only. So unit 2, we just did a lesson 2, but you need to make sure lesson 1 is done as well.